Hey geometry students, it's Mrs. Fellon again. We are going to go through lesson 1.2 in your student journals. So if you would please make sure you are on page 9 of your student journal. So down the bottom, page 9. We're going to kind of talk through some stuff and write down a few different definitions and go over some examples more today. You did a lot of vocab on the last video, so today we're going to kind of talk through different examples. All right, so postulate and axiom. Basically, it's a rule that we use in geometry. And so a postulate is a rule that we kind of take, it's like we accept it without proof. In other words, it's like already been proven. And so we know it to be true. So things that maybe you would think of as a rule is like, I don't know, you probably all know the Pythagorean Theorem, like a squared plus b squared equals c squared. Well, somewhere along the line, you know, Pythagoras proved that to be true for all right triangles, that the length of a squared plus the length of b squared will in fact always equal the length of c squared if you're talking about a right triangle. So right now we don't have to prove it every time we want to use that formula, right? So we take it for what it's worth. The work has been done. Fantastic. So that's kind of what a postulate or an axiom is. A couple other different definitions before we get into some examples. Coordinate. Okay, so if you think about a line like we talked about in the last section, right? So let's say I had line AB. So we talked about how to write that line using geometry, notation. A coordinate would be kind of like how you would label this line. So for example, I would call this x1 would be the coordinate of point A, or x2 the coordinate of point B. And so that's all they're really talking about when they say coordinate. It's kind of like a number almost, or a unit of measure that we're using, a position for that point. The distance would mean the difference between the 2 points. So the distance is the difference, which means subtraction, between the 2 points. So for example, a distance cannot be negative, right? Can't have a negative length or something like that. So when we talk about distance, what we're referring to here is an absolute value. So like, for example, if I wanted the distance between A and B. So first of all, when I write two letters like this, notice there's no symbol above them. There's no line segment, there's no ray, there's no, line, symbol or anything. What this means, when I have no symbol like this, it means I want to know the distance from A to B. That's what that kind of, vocabulary-wise, that's what that translates into. And so what this would mean, given my example, would be you would generally take the bigger number and you subtract the smaller number. But either way you do it, it doesn't really matter because you're going to take the absolute value of it. So remember, those symbols mean absolute value. And just as a refresher, absolute value means distance from 0. So again, that's why that number has to be positive, which is why we take the absolute value of it. So again, this is symbol. When I just write two letters next to each other, it means the distance between those 2 points. And then the x1 and x2 kind of pertain to the coordinates of those 2 points, by example. And then you just do a little subtraction, make sure that you take the absolute value of it, and that would be your distance. All right, we're also going to do today some construction. So what you're going to also need, I forgot to mention, is that you're going to need a straight edge and you're going to need a compass. So a compass that I recommend, and I hopefully, these are relatively inexpensive. You can get them on Amazon, a whole bunch of them. So if you guys want to go in and order a package of them and then share. But these are the ones I'm going to use in class. You probably have seen the other ones, which if you're comfortable with the other kind of compasses with like the little point and so forth, that's fine. I find these to be really easy, and they're cheap. And so that's why I'm going to use this compass. And then a straight edge, you can actually use the edge of this as a straight edge, or if you have a separate ruler, that would be fine as well. Eventually, you're also going to need a protractor for this unit, but not necessarily in today's section. All right, congruent segment. So the word congruent here is, I talked about in the last video, but basically what we're referring to is that they have the same length. So if we know that two line segments, let's say I say line segment A to B and line segment C to D, we know they're the same length, but notice that I don't exactly know what that length is. A lot of times we use the word congruent instead of equal here. because equal means that the measurements are the same, right? So like 5 equals 5 or 17 equals 17. Well, here, if I tell you they're congruent, you can know that they're equal, but you don't necessarily know what the measurement is. And so that's what the small difference between like congruent and equality is. A lot of times when you see congruent, you're going to see a symbol. You're going to see us use a little marking that looks like this. And so it's like a little dash on the line. Anytime any two line segments that have the same markings mean that they're congruent. So if you see two line segments and you see this picture, this in geometry language means line segment A to B. So there's line segment A to B is congruent. Congruent symbol is just that equal sign with the little curly thing above it to line segment CD. Notice I used the line segment, I used two letters, and I used the congruent symbol. You would not say that AB is equal to CD unless you knew the number here. Like if I told you this was, 5 millimeters and this was 5 millimeters, then you could say they're equal because you knew exactly what the measurement is. But based off of this example here, just because of the way I have them marked, you would say that they're congruent because you don't know the number, but you know that but by the markings, you know they're congruent. Remember, it doesn't really matter how many dashes, so that also means that AB is congruent to CD just because they have the same markings. So again, as long as they have the same number of little dashes on each line segment, that means that they're congruent. If one has, let's say it has 4 little dashes, this one has 3 little dashes, then that would mean they're not congruent because they have to be the exact same in order to be congruent. All right, ruler postulate. Not a very hard concept here, but basically what they're saying here is this is the distance between any 2 points. So that's kind of what I was talking to up here. You're taking the coordinates and you're subtracting them, and then you're taking the absolute value of it. So, and if this were, a distant, this was 10, if that was that coordinate, and this was 15, according to the distance between A and B would be 15 minus 10, and then take the absolute value of it. So you would say the distance between A and B is 5. Okay, again, obviously not all that challenging. Okay, what I'd like you to do now is grab a sheet of paper. And this can be a piece of line paper. You're gonna need to probably save this. So if you have a notebook, so like your notebook that you use for math, to kind of record any kind of, whether it's notes or whether it's just like practice problems out of big ideas and stuff. If you need to pause, you'll pause it now, but grab a sheet of paper and you're gonna need a compass and a straight edge. Okay, so if you've gotten that material, what I'm gonna have you guys do now is I'm gonna show you how to copy a line segment. To be honest with you, copying a line segment is really straightforward. And I understand that it's redundant because you could just use a ruler and like, if I gave you a line segment, okay, so I'm just gonna draw a line segment. So everyone just draw a line segment. I don't even care how long it is. Something that fits on your paper. So draw any length you want. If I asked you to copy this line segment, one way of doing this is to obviously grab your ruler, measure it, and say, oh, it measures, it measures 2.5 inches about. And I'm just going to copy it 2.5 inches. That's measuring a line segment, not copying a line segment. So what I'm referring to here is we're getting practice using our geometric tools. So even though it seems a little silly, we're going to use our tools to kind of help us copy this line segment. All right, step number 1. On this one, so draw a line segment, because normally if I asked you to copy a line segment, I would give you this right here, like a segment on a piece of paper. Okay, step 1, using a ruler or using a straight edge. So I'll say using a straight edge, draw a line. So I'm just going to use the edge of my compass here, and I'm going to draw a line segment. So we'll call it a line segment. And again, I'm going to put an endpoint at 1. Okay, step 2, place your compass. So we'll call this at point A and point B, okay? So put your compass at point A. So what that means is the middle of this little dot here in the middle needs to be right on that line segment. And then I'm going to ask you to measure the length. So you're measuring it, but not with a ruler. You're measuring it with your compass. So measure it with your compass. And so when you use these little compasses, you can use the top dot. So basically you're trying to figure out which dot or which little hole here is the one that matches exactly to the length of the coordinate for B. So the top one's kind of in between W for me. And again, obviously yours will be different because we all didn't draw the same line segment. But if I move mine to the bottom, it looks like this one is more of an accurate portrayal. So I'm going to use the X one as my length for line segment B. So you're going to put your compass on A and measure, using your compass, remember, the length of the line segment. So I figured out mine is right here at X. Okay, fantastic. Next, you're going to put your compass at the new endpoint. So put compass at new endpoint. And then I want you to mark off the length that you measured above. So the length of AB. So like, for example, I'm going to put my new compass here. I remember that I'm going to put my pen or my pencil into this little dot here because that's where I measured above. And I'm going to kind of swing it around. So this arc that you see here is rather important. That shows me that you used a compass and not just used a ruler. I do need to see this arc. I would like to see it exaggerated. You know, not maybe the whole page, obviously, but something like what I just showed you here would be great. I want you to be able to demonstrate that you can copy a line segment, and it's fairly straightforward. Put your compass here, measure it with your compass in terms of which, spot it measures up to. Put your compass on the new endpoint and mark off kind of with an arc of that new line. So now we'll call this D. So now we would say A to B. Line segment is A to B is congruent to C to D. And that's how you copy a line segment. Probably one of our more basic constructions that we're going to do, but we're eventually going to get through some other ones. So if you want to put all your constructions together, maybe in a separate section of your notebook, that's fine. But we are going to do quite a few other constructions along the way. We're just going to kind of do them as they come along. So, all right. Feel free to watch this video again. There's not a whole lot of practice on your homework with copying a line segment, so we'll have to do some stuff in class. But if you're really confused or whatever, don't be afraid to ask. Okay. I'm going to skip down to this part. We kind of talked about, congruence and what it means to be equal. The lengths are equal, and this means the segments are congruent. So there's just symbols here, and you can read through that. I'm going to skip down to where it says Postulate 1.2, the segment addition postulate. So what this is saying is that if between points A and C, so there's A, here's C, here's B, then A plus B, so this distance here, plus this distance here, equals the whole thing. To be honest with you, that seems a little common sense, right? I mean, like, obviously if you add this piece and this piece, it equals the whole thing. In an example, I'll give you an example of kind of how you might see this. If I give you a line segment, so we'll call this A, B, C, and I tell you that this length is 4, this length is, I don't know, I'm going to use a question mark, and this length is 20. So how you would use the segment addition postulate is basically just a subtraction problem or an algebra problem. You would say, okay, A to B plus B to C has to equal A to C. So this piece plus this piece equals the whole thing. So then you would say, okay, A to B has a distance of 4. B to C we don't know, so let's call it X because we love to use the label X. And then A to C has a distance of 20. We solve for X. Now, obviously, I don't expect you to write out this whole, equation every single time if it is this basic, but you'll come across ones that are a little harder, have some variables involved, a little bit more challenging, but obviously in this scenario, I just wanted to show you what it meant to be the segment addition postulate. All right, we are going to work through this extra practice page. So that's on page 11 in your student journal. All right, so it says, in exercises 1 through 3, plot the points in the coordinate plane, then determine whether A, B, and C, D are congruent. The first thing I want you to do with a pen or pencil, drawing your coordinate, your grid, your x-axis and your y-axis, so that we can graph these accordingly. All right, A, -5. 1, 2, 3, 4, 5, 5. So here's point A, here's point B. And then C is at 2, -4. 1, 2, 3, 4. Obviously, it's important that we know how to graph the points correctly. And D is at -1, -4. 1, 2, 3, 4. Okay. So they're saying, plot the points, and this is just more for practice, so for you to plot the points and see if they're the same length. And so obviously here, we're counting grids. So if you said, okay, this is 1, 2, 3 spaces, whether we're counting by, looks like we're counting by 1, so that has a measurement of 3. This one is 1, 2, 3. Those are both 3 units in length. We would say, yes, A to B is congruent to C to D. Because they have to determine whether they're congruent, right? And so I measured it with the grids, but technically we're just not really using numbers, so we're going to talk about congruency. I'm not going to go through the other 2 examples. I'm going to save those in case you need to practice them on your own. So again, you can plot the points, check to see that the distances are or are not congruent, and then write your statement above. So either you would say, yes, A to B and C to D are congruent, or you'd say, no, they're not. All right, skipping down. So here are some basic examples of how you use that segment addition postulate. They're asking to find the length of VW. So V to W is right here. And again, I don't expect you to set up an equation, but if you were to set up an equation, you might say the distance from V to W plus the distance from W to U has to equal the distance from V to U. So that's how you'd set up the algebra problem if you were actually going to follow the postulate exactly. And then you just fill in what you know. So you would know, you don't know this length, but you know this length is 8, and you know this length is 31. And so you would subtract. And then lastly, I would like you to say the length of V to W is 23. Because technically we're not really solving for x, we added x. And so this is really what you're doing here. And then here's just a couple more examples, right, of how to, come up with this length, V to W. Number 6, the only difference is V to W is this whole length. So really, all you're really going to do is add those 2 numbers together. So you'd say V to W is equal to 75. Again, I don't think this is going to be awful challenging for you guys, but I just wanted to show it to you nonetheless. Story problems tend to be a little more challenging sometimes for people. Let's read it. It says a bookstore and a movie theater are 6 kilometers apart. So bookstore, movie theater are 6 kilometers apart. Okay, so that means this length is 6. Got it. A florist located between the bookstore and the theater is on the same street. So florist. The florist is 2.5 kilometers from the movie theater. So this length here to movie theater is 2.5. How far is the florist from the bookshop? All right, so obviously the math here isn't all that challenging. It's more about getting the picture correct. And so when you look at this, you are solving for this length here. So essentially what you're doing is you're taking 6 and you're subtracting 2.5. And so you get 3.5. So you'd say the florist is 3.5 kilometers from the bookstore. If I ask you a story problem, technically you should answer your question, not just say, x equals 3.5. The question said, how far is the florist from the bookstore? So you'd answer that question and say the florist is 3.5 kilometers from the bookstore. Okay, that is it. If you have any questions, remember to write them down, highlight them, whatever you got to do, and we will go over them in class. If it's something that's really, really important, you can always email me, and I can try to explain it via email if I can't wait till the next class period. All right, bye for now.